So, hi everyone. Today, I will teach you about cautions and relations and how can we apply it. So, let's talk about what a relation is. A relation is any set of ordered pairs. For example, these are called relations. Now, on the other hand, a quotient is a relation where each element to the domain corresponds to exactly one element in the range. All quotients are relations, but not all relations are quotients. For example, now let's see this relation. We have two x values or domain that is repeating, which is the number 4. These are the x values. We have two domain that is repeating. The domain does not correspond to exactly one element in the range. So therefore, this is not a function. It's just a relation. It is important to understand the domain in range to analyze a function. This, the x value would be our domain, and the y value would be our range. A domain, by definition, is the set of first coordinates. Oftentimes, it is the value of x. A range is the set of second coordinates, which means that it is the value of y. Remember that a function are things that have no repeating x values or no repeating values in the domain. By looking at the domain of the relation, you can easily tell if it is a function or not. So for example number 1, is the relation a function? Just by looking at the domain, these are our domains, which is the x values. You can easily tell that this relation is a function because it has no repeating values in the domain. So this is a function. We write down now our domain and range. Now we list down the domain in order. So our domain is 1, 3, 4, and 5. Now remember The range are the values of y. So this would be our range. These are the values of y. So we list down in order. So it would be 3, 7, 8, and 9. Then, to make a mapping diagram, we will list down each domain in range in a circle. So the domain is, this will be our domain. And this will be our range. Then, to make a mapping diagram, we will list down each domain in range in a circle. So the domain is 1, 3, 4, and 5. So the range should be 3, 7, 8, and 9. And then, we're just gonna draw arrows pointing the domain to the range. So we will use this relation to plot our mapping diagram. 4 and 3, 5 and 7, 3 and 8, 1 and 9. Another example. Negative 1 and 3. Negative 2 and 2. 0 and 1. Negative 1 and 4. If the relation a function, looking at the domain, you can tell already that this is not a function. Why? Because it has a repeating value of the domain, which is the negative 1. However, you can still list down the domain and range and plot the mapping diagram to see if it is really not a function. Domain and range. So, our domain would be negative 2. Since in this case we have two negative 1 or two repeating values of the domain, we only have to write the repeating value once. So it would be negative 2, negative 1, and 0. The range should be the y values. So it would be 4, 1, 2, and 3. So what would be our range? Very good. So we will do the same technique in the mapping diagram. So our domain will be the negative 2, negative 1, and 0. Our range is 1, 2, 3, and 4. So looking at the relation and order pairs, we can now plot the mapping diagram. Negative 2. Therefore, this is not a function because of this. The domain doesn't correspond to exactly one element in the range, so this is not a function. Now, let's talk about function notation. We have x and y values. We will substitute the value of y into f of x. This means the function of x. For example, f of x is equal to x squared minus 6. If I want to find f 4, that means everywhere I see an x, I will substitute it with 4. So this will be f of 4 is equal to 4 squared minus 6, which is equal to 6. 4 squared is equal to 16 minus 6, which is equal to 10. So, 4 and 10 would be our ordered pairs. So this will be the ordered pairs 4 and 10. The 4 corresponds to the domain and 10 to the value, and the f of x corresponds to the range or the value of y. I hope you get the idea of the function and relation. Thanks for watching. Have a good day.